Have you ever stopped to wonder how your phone can just instantly spot faces in your photos or translate a sign in real time? Well, it's because essentially an AI supercomputer has been shrunk down to fit right in your pocket. So today, we're going to break down the brilliant paper that revealed one of the key tricks to making that happen, ShuffleNet. All right, let's get into it.
And that really is the central question, isn't it? It's not just about making AI smaller, it's about making it smaller without making it dumber. And the answer really lies in this fundamental clash between two very different worlds of artificial intelligence. You see, on one side, you've got your data center AI. We're talking massive, power-hungry models running on racks and racks of servers. But on the other side, you have the dream of mobile AI. Something tiny, something that sips battery, and something that gives you an answer instantly, right there on your device. Bridging that gap, well, that's one of the great engineering challenges of our time. So let's really set the stage. The whole problem that ShuffleNet was designed to tackle was about taking the raw power of those huge networks and somehow squeezing it into the palm of your hand. Okay, so picture this. It's around 2017. The AI world is just dominated by these giants, like ResNet. And these models were achieving absolutely incredible, superhuman accuracy on things like image recognition. But they were so expensive to run, just way too big, too slow, and way too power-hungry for things like mobile phones or drones or robots.
And you don't have to take my word for it. The authors of the ShuffleNet paper pointed this out directly, and it really shows you the scale of the problem. We are talking about billions, with a B, of calculations just to process a single image. That's just not going to work on a device that runs on a battery. No way.
And that brings us to the solution. The researchers at MegV Inc, they zeroed in on a very specific bottleneck and came up with this incredibly elegant fix. Now, their diagnosis of the problem was just brilliant. See, it wasn't that the entire network was slow. No, it was one very specific operation, something called a pointwise or a one-by-one convolution. In the top models at the time, this single step was responsible for over 90% of all the math. So you can see, right, if you can fix that, you can pretty much fix the entire efficiency problem. So their first idea was to use something called a pointwise group convolution. The best way to think about this is like a big, busy kitchen. Instead of having every single chef work on every part of a meal, you split them up into groups. Each group works in its own aisle on just one ingredient. It's way, way faster, but it creates a brand new problem. Just like those chefs who can't talk to each other across the kitchen, this grouping method created what they called information silos. The work from one group was totally cut off from the others. And that's a big deal because it blocks information from flowing through the network, and that really weakens the AI's ability to learn.
But the team came up with a breakthrough, a solution that was so simple and so effective that it almost seems obvious now, looking back. They introduced the channel shuffle. It's exactly what it sounds like. After each of those grouped operations, you just shuffle the channels. It's like shuffling a deck of cards. This one simple move guarantees that in the very next step, every group is getting information that came from all the other groups. The information silos, completely gone. I mean, just look at this comparison. It's so clear, right? On the left, you see the problem. All the information is stuck in its own lane. But on the right, after the shuffle, bam. Everything is completely mixed. Information is flowing freely everywhere, which lets the network learn much richer patterns. And by combining that efficient group convolution with the clever channel shuffle, they created this, the ShuffleNet unit. This became a brand new fundamental building block that was both computationally cheap and really powerful. It's the core of the whole architecture. So the theory is beautiful, it's elegant, but how did it actually perform against the competition? Okay, let's look at the numbers. And this is where it gets really, really impressive. When they put it head-to-head with MobileNet, which was its main rival back then, on a super tight computational budget, ShuffleNet was way better. It got a 7.8% lower error rate. I mean, that is a massive improvement in this field. But here it is. This is the single most stunning number from the entire paper. 13 times. That's the actual real-world speedup they got on a mobile phone's ARM processor when they compared it to AlexNet, an older, famous model. This wasn't just some theoretical gain on a spreadsheet. It was a proven, practical speedup that made high-performance AI on your phone a reality. And this table right here, this shows you exactly what that 13x means in practice.
AlexNet took 184 milliseconds to run. ShuffleNet, doing basically just as well, took about 15 milliseconds. That is literally the difference between an app that feels laggy and an app that feels completely instant.
So, what's the lasting impact of this clever little shuffle? Well, its influence goes way beyond just this one model. ShuffleNet really helped kickstart this whole field that's focused on hyper-efficient AI. It proved without a doubt that you didn't need some computational monster to get top-tier results. And the core ideas, using efficient operations and making sure information can flow freely, those principles are fundamental to a ton of the AI features you use on your smartphone every single day. Which kind of leaves us with one final thought. The core insight here is so powerful, just intelligently mixing information can dramatically boost efficiency and performance. So the real question is, beyond just computer vision, where else in AI, or heck, even in other complex systems, could a simple shuffle unlock a whole new level of capability? This is for entertainment purposes only.